So, today's warm-up question is, what type of boundary causes seafloor spreading?
Is it a magical boundary?
Is it an out-of-this-world boundary?
Oh, obviously it's a divergent boundary. I hope you guys are smarter than those people. So, the first thing I want you guys to look at today is you have brand new vocabulary words. I still want you to make flashcards and study these words, but if you don't have the materials to make them on index cards, you can do them online using Quizlet. I have a link below in the Google assignment so that you can figure out how to do that. Remember, even if you make them online, you still need the word, the definition, a picture, and an example. And I'd say I'm sorry about the cartoon on this slide, but you know I love a good science pun. It's not my fault. So let's talk about earthquakes. Earthquakes are the shaking and trembling that result from the movement of rocks beneath the Earth's surface. Faults hold potential energy. Remember, potential energy is stored energy, and it's converted into kinetic energy or energy of movement during an earthquake. So you guys already know that the Earth's crust and the rigid upper part of the mantle create the lithosphere, and the lithosphere is broken apart into plates. Plate movement produces stress on the crust, adding energy to rock and forming faults. Stress increases along the fault until rock breaks, producing an, you guessed it, earthquake! The area beneath the Earth's surface, where rock that is under stress breaks, triggering an earthquake, is called the focus. But the point on the surface, directly above, is called the epicenter. Did you see the picture? The picture makes so much more sense than what I just said. Make sure you study it. Now, let's talk about the waves that produce earthquakes. The first one we're going to talk about is seismic waves. Seismic waves are vibrations that travel through Earth, carrying the energy released during an earthquake. I'm keeping that take. Then there's the more dangerous surface waves. Surface waves carry energy away from the focus, through the Earth's interior, across the surface. There's 3 different types of seismic waves. The first one is called P waves. The P stands for primary. Primary waves are the first waves to arrive. They compress and expand, push and pull the ground like an accordion. P waves are compressional waves. S waves are secondary waves. They come after the P waves. S waves vibrate side to side and up and down. S waves are transverse waves. Surface waves are waves that reach the surface. They move more slowly than P and S waves, but they are very destructive. Scientists use a seismic graph to measure earthquake waves. Look at the seismogram on the left. That's the report that comes from the seismograph. You can see on the report that the first waves are the P waves, and as time goes by, you see the S waves, and then the big destructive surface waves. The picture on this slide is of the San Andreas Fault. You know what type of boundary that is. It's a transform boundary. This fault can be found off the coast of California. So we've studied lots of waves this year, but all of these waves, light waves, sound waves, earthquake waves, they all have something in common. They all carry energy. When we measure earthquakes, we use a scale called the Richter scale. It's a scale from 1 to 10, depending on how severe that earthquake is. Hopefully you learned a little bit about earthquakes today, and a lot of it about how Aziza needs to get out of this house and out of quarantine, because I think she's losing it a little bit. I love you guys and miss you. Bye!